Why do some of my videos have 500k views, 350k views, and others have only 700 views? I wanted to know if there are some special patterns hidden inside these videos that blow up. Not just transcript-wise, so what I say verbally, but what is on the actual screen, what is being shown visually to the viewer. So in order to do this, I turned all 88 of my videos into actual structured data, as you can see right here. Now you can see that the normal stats are all here, like the date, the title, the duration, the views. Then we have some other stats like to view ratio, and so on. So this is just a normal table of, the normal stats of the video. But if I go over to timelines, this is where it gets interesting, because here we have the visual layout of my videos. And how I did this and how this is actually possible is via Kimi's API, which I will get to later. So if we take a look at one of these entries here, for example, the one with the most views, we can go in and we can look at the scenes of this video. So we have the spoken transcript, which, is available to extract via some audio to a text model like Whisper. So we have my verbally spoken lines here. So someone figured out exactly where censorship lies within an AI model. But then via Kimi, we also have the visuals. So for example, here we have, if we remember this now, facecam hook with headline, creator speaking to camera. Then the next scene contains revealing the heretic tool on GitHub, GitHub README for heretic tool. So let's take a look if we see exactly that if we open up this video. So first we have me speaking to the camera, which was the first scene. And then it goes over to the GitHub's README, which I'm pointing at right now. And it goes closer and then it shows this cool scatter plot, which we can see right here, explaining a iteration technique with scatter plot visualization. So it works. And we can now categorize these scenes. Awesome. How I did this for all 88 of my videos, I will show you now because it's actually a lot easier than you could imagine. So let's go over to my simple diagram here to show you how it works, just really fast. So we have my TikToks, of course, which in order to get all the URLs, in order to download these videos, we need to use a tool like API, for example, which can scrape my entire TikTok page, get the IDs, the URLs, and the performance stats. Then we use yt-dlp, an open source tool, to download the videos locally. And here's where the interesting part happens. So we split the MP4 in half here. So we take the actual visual video and send it one place, and then we take the audio and send it another place. So in terms of the audio, we send it to Whisper, which is a audio to text model, which just transcribes audio. And then we can get a timestamp for each word. We can sample it how close we want. We can sample entire sentences, or we can get a timestamp for every single word. So that is what this part retrieves on screen right here. So the Whisper part. And then we have the Kimi part. And I find this extremely nice because Kimi has basically a video upload API endpoint. So we can simply, from our computer, our local computer, we can upload these MP4 files directly to the Kimi API. And I don't think this is available on any other provider, from what I know. And this basically allows us to extract the scenes from the visuals. As long as we send a kind of prompt alongside this video, extract each scene with timestamps, with descriptions. There's a lot you can do there, actually. I might get into it later. And this costs basically nothing because this is Kimi. It's really cheap. I think it's like 5 cent dollars or something. But then basically we get a JSON output or some data output with the scenes and timestamps and all of this from Kimi. And we also have timestamps from the Whisper. And this is where the timestamp alignment happens. So we want to kind of pair the scenes with the transcript in order to have the full information of not only visual, but also audio. So then we just align using the timestamps from each of these tools. It's pretty easy. And then finally, we will have something like I showed you earlier with the stats of the video, the actual transcript, the words I'm saying, and then the visuals. And this is how easy this is to do. So this is basically just a workflow that I can call from my computer at any point. Now, full disclosure here, this video is sponsored by Kimi, and it is also the same company that I use to do the visual analysis of the workflow. So Kimi right here, I use K2.6 for the analysis, but now K2.7 code is out, which also has this same endpoint, which I would probably gladly upgrade to actually. So they have this super nice video endpoint. As you can see here on screen, you can just simply upload the video URL to the model right off the bat, which is exactly why I'm using Kimi for this workflow. But I kind of want to zoom out a little bit because the interesting thing here is not TikTok analytics. It is that you can take this annoying blob, which used to be like, you having to watch a video manually. You can take that, you can feed it to an agent, and then you can make that agent turn it into actual text, which another agent can reason over. That is the interesting part. So any part where the visuals contain some kind of evidence or proof can now be turned into data that an agent can reason over. Now, I use TikTok as my example for using this workflow because I had real stuff that I wanted to extract, like real patterns that I wanted to understand. And the visual part was a real part of that. So my TikTok use case is just one of many. I mean, you can use this for ad creatives, tutorials, just any video which contains evidence and you want to analyze just the visual part of it. And let's take a look at what I actually learned from this analysis because it is really interesting and I think this will have a huge impact on my coming videos. So let's take, for example, this front-end skill video of mine, which is my second most viewed one. And we can see here that immediately after the hook, which lasts for around 3 seconds, this is important, there is proof from the get-go. So immediately after the hook, I show something on camera which hooks the viewer up again. So we can even take a look at this video and see what is happening. So we have the hook for the first 3 seconds, which is me talking to the camera. Then I'm showing something on camera, which is the front-end design skill. So this is the proof. And I'm also saying how many installs it is. Then immediately after that, I'm showing another proof, which is showing how well these websites are created. So here you can see I'm showing 3 different examples. And yeah, that's like the first, I would say the first 10 seconds of the video is the majority of why viewers stay to watch. So we don't have to watch that much more there. If we now go all the way down to one of my biggest flop videos, we can see a huge distinction here. These are basically polar opposites on the spectrum, because here we have the hook like normal. Every single video has a hook. I've always known that the hook is the most important. And sure, it does a decently good job at creating this curiosity that makes viewers stay. But then we see the problem. There is no proof until 33 seconds in. There is just problem setup, a little more context, problem setup, setup, and then finally, at 33 seconds, there's a demo. So that was the main pattern that I found in this data. It was essentially that the videos that actually popped off did not just explain better, they made the proof visible faster. So I will, from now on, apply this principle to all my future TikTok videos, and that's for sure. So hopefully I will see some massive improvements in views. We'll see. That's kind of like the whole experiment that I will have going on for the coming weeks and months. So the results are interesting and all, but the part that I really expected to hurt in this whole workflow was, of course, the API costs. It's always the API costs that cost a fortune. But as I touched on earlier, in my use case, one one minute video costs around 5 cents. And as you can see here in my consumptions, when I was playing around with this a lot, like running probably a few hundred videos through the API, I only went up to around $2 of usage for that day. And you can see this is barely costing anything. I think I started experimenting this project around I don't know, 45, 42, I think, in balance. And now I'm at 37. So as you can see, using Kimi, this is barely a cost. So you can play around a lot. But let's go over some of the caveats, because of course Kimi doesn't analyze every single frame of the video. That would be insanely expensive. And also, of course, Kimi does not hear the audio, so you will need a separate model for that, which I used Whisper for. I run it locally, it works great. I would highly recommend, if you have any kind of like a GPU or something, you can run Whisper locally, it's super quick. Now, the label themselves of the scenes are not entirely perfect either. I mean, this highly depends on what kind of prompt you send alongside the video. For example, I mean, it's like, you know, it's context engineering, prompt engineering. It comes alongside video analysis also. You can specify like how many like, you know, JSON fields you would like Kimi to send back to you. I made it very, you know, broad. I only wanted like a pretty simple scene description. But if you know, if you wanted to go into more detail, then you can say that in the prompt. It gives you more details per scene, but of course there's more reasoning and, you know, then higher latency also. But for this use case, I just wanted some kind of simple scene descriptions. And also, as you can see, this does not guarantee a, you know, viral formula. It simply like gives me a map over what seems to be working and what seems to not be working. So I kind of still have to use my own, you know, thinking to kind of see what might be working. Of course, I can use the aid of an agent to kind of see the data and like find these patterns, which I have done, and it has, you know, arrived to the same conclusions that I did, which is that visual proof fast is really good. So if you are a creator, maybe you can take something away from this video also, alongside the cool visual analysis you can do with agents such as Kimi. Now, in the description below, I will link a public repo to my analysis that I made myself. You can go check it out, look in it, you know, adapt it to your needs, anything you want really. But the bigger takeaway from this video is definitely that videos do not have to be something that you manually watch anymore. There are use cases where you can feed like AI agents actual videos now, so not just get the transcript out, but actual, you know, descriptions of scenes and all of this. So that is the main takeaway of this video. It's really cool. I can't wait to find more use cases for this. And maybe you guys can let me know some of the obvious use cases you guys might be thinking of, because yeah, I just mentioned a few in this video. But yeah, I hope you enjoyed. See you. Peace.